All right, great. So, welcome to the session, and I'm Sandeep Giri. I'll be uh, I'll be presenting this session. All right. So, please introduce yourself before I start. So, we have Sudhendra working as a product manager at Aris Group Global. Great. We have Kaushik from Triple ITB. We have Venkat from JP Nagar. Okay. We have Akib working as a software engineer in Mindtree. All right. Great. Great. We have Madhi and all right. And so Mayur's question is that how to use big data. You will get to know as we go forward in the session. And we have Vivek Kulkarni works at Oracle in the Bangalore. Great. Great. And we have Ram Kapula. He works at Oracle. And we have Gaurav Kalra, who says that he is a big data noob, have taken introductory class, doesn't use it at work, interested in project ideas. Great, great. We have Chaitanya and Somesh. All right. Suman, are you able to hear me clearly now? All right. So we have Veena, we have Lokesh, and we have Ashutosh, we have Krishna Maleshwaram, and we have Neelaranjan is working with HP. Great. We have a great users as of now. We have 63 members online right away. More will be joining soon. So there will be a lot of questions, and I will regret that I'll not be able to read all of your introductions because there are actually 63 introductions. No worries. So I'll go through your profiles again, and it'll be all right. So I'll just go through your profiles again once more because each of everything is getting recorded. All right, including these questions. So, so the welcome to the session number one, which it's a first session out of our 11 sessions, and the duration of this session is 3 hours. In first half, we will try to understand what is big data and general understanding of when, how, and why of big data. In the second half, we are going to discuss Hadoop architecture. All right. This session is being recorded, and recording and the presentation will be shared with you after the session with all of you. And to ask questions, you have to type the questions the way you have typed just now. Everybody except the instructor, which is me, is muted. And so please ask your questions in the questions window, and I'll read out the questions before answering any of them. To get better answer, keep your messages short and avoid chat language. All right. And this is the session one of our full course. Rest of the course will have fewer attendees, at most 25 attendees, including myself, will be there in our usual session. So and in the rest of the sessions, you will be able to see each other's questions. In here, right now, this tool does not allow us to see each other's question. So I'll have to read the questions and then. All right. So great. So Vivek is saying that please can you cover use cases where and how big data is used? What problem is it solving? Then BI and sure, sure. That's the exact discussion we are going to have today. All right. Yes. So you can download the recorded session later on. All right, Aki? Great. Now, first of all, welcome to Big Data. Myself, Sandeep Giri. I'll introduce myself in a minute. And so, about No Big Data, the company which we have started, w- our there are few unique selling propositions we have. One is we only have expert instructors, the people who have either worked into the core of Hadoop or have used Hadoop in their organizations. Those kind of instructors are the one we employ. Okay. We are not focusing too much on the pedagogy aspect because we believe that a technology person with a decent ability to convey is more useful than are not more useful to the students than a non-technical person or non-expert instructor but having a great communication. So the trade-off between the two, we are trying to get, our first priority is the person should know what technology we are talking about. He should have a very good understanding so that if a student asks a difficult question or students ask a question which is difficult, the instructor is able to answer. So that is the primary importance which we are doing at No Big Data. And second is the cloud labs. We provide a playground for all our students, just like as if it's an enterprise world, the way it was there at Amazon for us, the way it was there for at InMobi for me. Similarly, we have set up cloud labs so that you can right away start working on it. All right. Next is that learning management system. The access to the learning management system will be lifelong. It contains presentation, it contains recordings, it contains assignments and quizzes, and it contains the project work. So all of these details are available in LMS, and the access will be for you for lifelong. Next is that we provide real life project to the few who complete our usual assignment and project work, and and based on their choice, if they want only then we provide a real life project. Next is the course completion certificate. The course completion certificate is something we provide, and all right. So next is we have a 24/7 support, and we have a great alumni of No Big Data with which you can stay connected. All right. So Kaushik's questions is that for other sessions, how are the candidates selected? So Kaushik, the basically rest of the sessions other than the first session are paid. So you need to go to our website and enroll. This one is public and open for everyone. All right. So all right, all right. So Venugopal, there will be some way to reduce the volume on your device. I do not want to reduce my volume because there are other people who are okay with the volume. We have Revati. All right. Okay. Great. So Vina's question is, what do you mean by real life project? Real life project as in a project from industry. All right. There are a lot of companies who are trying to connect with us, trying to get their big data work done, but we only take up the work only if we have really committed students available. All right. So the industry, uh, Akib's question is which industry? Industry, there are different kind of industries. All right. So, all right. So, Akib's point is that can you please name some? One was, okay, one was a company, a telecom company from Saudi Arabia who was trying to work with us. Then there is another company who is into banking, who is trying to do a reconciliation using big data. And there are a few more companies. Great. So now moving on. All right. About myself, I'll be the instructor today. I'm Sandeep Giri, and I have done, did my graduation from IT Roorkee in 2002. After that, I was working with a company called DE Shaw, where we were churning terabytes of data when the world did not actually go beyond handling few hundred GBs. Okay. So at Disha, we did a lot of grid computing and parallel computing. And afterwards, I started another company called Into Document Management System. And afterwards, I joined in Mobi, where I built Recommender after churning 200 terabyte of data. And afterwards, I joined Amazon, where I built a platform similar to Apache Storm, which basically does a lot of parallel computing. All right. So now in 2014, we started No Big Data. And since then, we have been able to train a lot of people into big data domain. All right. So in today's class, we'll start with the usual discussion. So what exactly is big data? What is your understanding? Akib's answer is the data hard to process in simple words. Anybody else? Quick? Yes. So Sivam's question is that I'm totally new to big data. So probably everybody in this session is new to big data. No worries, Sivam. Okay. I'm asking this question because I just want to understand what is your version because this word is very heavily abused as of today. Everybody has their own definitions. So Vivek's answer is that it's a data analytics platform. Vivek, this is not a data analytics platform. Big data is just data which is big. It's as simple as that. All right, we have Venugopal's answer, Revati's answer. So wow, so many answers. Great, great. S All right. Yes. So most of you are right. It's a simply data of very big size which you cannot process using usual tools, and for that you would require distributed architecture. Okay. So basically, when we talk about big data, please understand this. So big data is not a technology. Big data is not a technology platform. Big data is simply data of huge size or in and to handle such kind of data, your usual tools fail. And when I say handling means storing and processing. Processing can be of various kinds. We'll discuss it later. And so to handle such a data when your usual tools fail and you realize that there is no other way than using a distributed architecture. Your usual tools fail not because those tools are buggy, but those tools, but the hardware itself has got a limitation. We'll discuss it again. Here, the most important thing you need to understand is the distributed architecture. Okay, what does it mean by distributed architecture? Okay, so there are two kinds of computing, and there are actually many kind of computing, and we want to just differentiate between distributed and parallel. What does it mean by distributed computing? Distributed computing is as simple as we connect multiple computers together in the network and design the software such that the software can utilize all these computers simultaneously to solve our problem. So such software is known as distributed software or distributed application, program. Okay. So, or distributed computing. So a distributed application or a distributed platform is which uses multiple computers and solves the problem. Now, distributed is sometimes confused with parallel. Okay, in parallel computing world, you have but multiple processors sharing the same RAM, and that is generally the biggest difference between distributed and parallel. But interestingly, wo- lots of work which was done on parallel computing is still valid for distributed computing. Is everybody clear about distributed and parallel computing? All right. So Akib's question is, when you say you built something similar to Apache Storm, you mean you coded it? Yes, we built it from scratch. All right. We needed a little bit different from Apache Storm. That's why we built it. And we have Madi and all right. All right. Now we have Sivam's question. Sivam says that can you name some of the usual tools? When we say usual tools, thank you for that question, Sivam. A usual tool could be, file storage. Our usual file storage or file system is actually a tool which lets you store files into the various storage devices. So usual file system are not able to handle the amount of data we require. Okay, the limitation is that we will see this limitation while we're designing the HDFS. All right, we'll discuss it and then we will understand the limitation of usual file system. Similarly, usual file system could be our normal way of executing program. That's also another tool. So another example of usual tool is your normal, say, operating system where you double click on an exe and it runs. So this exe runs on only this machine. It doesn't run on multiple machines. Okay. Other usual example of usual tool is the database. Okay. Your most of the work were happily done by our normal database so far, an RDBMS, MySQL, Oracle, or MS SQL. But when you deal with big data, these databases hit their own limitations, hardware wise as well as software wise. Yes, the slides will be shared with you. All right. So Veena's question is there a certain specified size above which we call the data as big data? Okay, not really, not really. It's all a combination of what kind of things you are trying to achieve. When you can't achieve your objective using a single computer, and then you realize that it's not only the software which is hurting you, you have hit the upper limit of the hardware, then you decide to move on to the big data solutions. Now, Akib's question is the language used, the in what? Please, can you take the questions not related to the slide later? Yes. Thank you, Vivek. Yes, I think that is what I need to do. I'll take only the questions that are related to the slide. All right. Okay. All right. So I'll keep that question I can take later. You can remind me or drop me an email. Then we can answer that question. Okay. All right. We have Satya's question. Thank you, Satya, for that question. Could you please put me in a scenario on using distributed and on a parallel computing? Okay. So say you have to do a genome sequencing and there's a lot of combinations need to be tried, then you go for a parallel computing when your processors become the bottleneck. All right. When all of the resources or any of the resources start becoming the bottleneck, the resource may be the CPU, resource may be RAM, or resource may be anything, then you choose to go for distributed. Okay. Say for example, you are trying to find the standard deviation of few billion records. In those cases, it's not only the CPU, it's not only the RAM which will become the bottleneck, it all the way you are reading from the disk, that speed will become the bottleneck. We'll talk about it again. Yes, Shivam, that's correct. Parallel computing is multiple processors on the same machine. All right. So another relevant question here, good, is what kind of data? I mean, Oracle DB, we can process blob and clob, etc. Is it possible here? Yes, definitely. All right. Now, going back further, so everybody is clear about distributed and parallel computing, right? Great, great. Now, when we talk about variety, structure, unstructured, what does it mean? Okay, it's I will the sole objective of this discussion today is keep the definition very clear. Okay, not maybe a little bit politically incorrect, but I'll keep the discussion the definitions very clear so that none of you go confused from the discussion. All right. So the structured data is something in which we know that these are my input data types, as well as you know that uh, these are my input fields and what are their data types. So for example, in case of a database, you know that in this table these are the columns and these are the data types of the column. In a JSON structure, you know clearly that these are the fields in the object and these are the data types of that object. So both of this example, the JSON as well as the database is structured data. Now now the semi-structured data. Semi-structured data is in which we know the input fields. For example, CSV file. CSV file is comma separated file. Okay, if you have used Excel sheet, you can export the file into CSV file. In the CSV file, we clearly know that how many fields are there and what are the fields. But what we do not know is what are their data types. To understand the data types in a CSV file, you need to parse the data or supply some extra information to understand what kind of data type each column has. Okay. Next is the unstructured data. Unstructured data is something in which neither we know what are the fields in the input, nor we know what are the data types. Okay, of course we wouldn't know the data types if we even don't know the fields. For example, Apache log contains only the raw data. Therefore, Apache logs are unstructured data. To understand the meaning of the fields, we need to parse the data, and we need to put an effort in figuring that out. Okay, so this is the difference between structured and unstructured data. Okay, all right. So another question from Vidhi is it possible to use inside parallel computing? We can use distributed computing. I mean, in a single processor, we can use distributed architecture. Not really. Then we won't call it a distributed architecture. All right. Although we just do that kind of thing for our learning purpose. Okay, that on single machine we install multiple servers, we behave as if there are multiple computers on the same machine. We do that for only learning purpose, but that's not something the purpose of distributed computing. Okay, all right. So Suresh's question is how the data is managed without knowing the fields and data types. So managing data in which you don't know what is inside. Okay, I mean, you have always been managing such kind of data, haven't you? Putting in the file system, saving it, using it as a blob. So you have always been managing that kind of data. Okay, all right. So Arun's question is, can you give some more example? So structured data, I gave an example of having your relational databases, and that's structured data. Relational database tables, JSON data, and sometimes XML data as well when you provide the extra definition with XML. But XML data is mostly semi-structured data. Okay, because inside XML, if you put a number, okay, you have to clearly specify that this particular value is a decimal or a number, and this particular value is a non-number. Okay, although you are free to not define that way, and hence most of the XML data is considered semi-structured data because you don't know the data type of the field. You know the what are the fields in the input very clearly, but you don't know their data types mostly. Okay, unless of course by supplying extra information in the form of XLT. So XML is semi-structured, so is the CSV file. And in unstructured data, it could be video, it could be binary, it could be zipped file, or it could be any other. In semi-structured, your Excel sheet lie in the semi-structured. Okay. So Veena's question is, do we first separate different kind of data and then process it differently? So yes, when you are processing data, you need to know what the kind of data it is. If you don't have a you don't have a clear definition of the data, then you will have to make it clear whenever you want to process it. All right. So here is the traditional definition, and be aware that I will stick to our definition of big data. That big data means any data for which we require distributed computing, meaning multiple computers, and therefore all the tools covered in these session, all the tools around 12 tools we discuss in the sessions, all these tools are actually distributed computing, meaning all these tools parallelly run on multiple computers. So all the tools which we'll discuss as part of this course are all distributed computing tools. None of them is a usual single computer system. So here is the traditional definition, although this definition will not take us anywhere, but let's discuss it. Okay. So because lots of people keep on asking the same definition, and when somebody asks them about big data. So the definition given by IBM is volume, velocity, and variety are the and then now they have added veracity, and I think they have also added value. So these four V's are the something which describe data, okay, which describe big data. Whether you're So these are the characteristics of the data which might make data as big data. Okay, so starting with the first one, volume. If you have to store 100 terabyte of data, you may not be able to store it on the usual system, and that's where you have to have a distributed system to store 100 terabyte data. All right. Now, if your data has got a velocity, velocity can be the way right now when the way I'm delivering this session, and this session is being up. I mean, the video from my side is being uploaded onto the server and then distributed to around 100 people. Okay, and this is happening at a very fast pace. So that is velocity, meaning there's a lot of data movement at a very fast pace. Okay, so and the other example of velocity could be the number of requests the world is sending to Facebook. Okay, every time you open up your device, it refreshes your Facebook feed and gives a call to Facebook. Now imagine number of requests hitting the Facebook servers. Okay, so that is velocity. So number of at what pace you are accessing data. All right. In the Facebook example, the volume would be the total number of data accumulated so far in the Facebook premise. Now, third characteristic of data is variety. Sometimes your data is quite complex. But let's take a case of Google Maps. Okay. So even though Google Maps could be, say for example, the maps for a state could be as big as 100 GB. Now, to process Google Maps, to find out the location from one place to another, not Google Maps but normal maps. So you will have hardly 200 GB data, and to find the location in this 200 GB data from one position to another position within say 5 seconds of duration, it is actually very difficult task. Okay, so for solving such kind of problems, for handling such kind of complex data, you require different set of tools. You require a distributed system which can solve your problem parallelly on multiple machines. And that's why the variety of problems can make any small data problem a big data problem. Okay? So similar is the case with lot of gene sequencing, classification, categorization. Although the data might be small, but solving that particular problem might require you multiple computers parallelly. Okay, if you try to do it on a single computer, it might take maybe it might take too much of time, which is something you would not like. All right. Now, fourth is veracity. Term is very absurd. Okay, but let me try to describe to you. So, veracity as a term means the data resulting due to confusion, the data in doubt. Okay, so whenever you deal with lot of data, what happens is you basically end up having lot of intermediary data or data from multiple sources. Okay, data from multiple sources. For example, uh, you, so so let's take a case of, say you are trying to gather some statistics on temperature. So you asked multiple people to you bought the data from multiple people, and this data, one vendor is giving you the data that contains the temperature per zip code wise. The other one is giving the temperature per second and per zip code. The third one is giving the location, the data of temperature per minute, but per GPS location. Now, which one to choose? Out of these three data sets, which one to choose? But till the point you decide on churning this data, you have to store and you have to compare, right? And which itself is a processing requirement. So effectively the veracity led to the volume. Okay, so this veracity, data in doubt, might cause the volume, and hence because of veracity your small data problem might become the big data problem. All right, did I make sense? Any questions on this? All right, all right. Okay, so with these questionnaires, veracity is not clear to me. Okay, let me explain with another example. All right, so let's say you have two sets of data. I mean, veracity generally means that you have different sets of data. You are not really sure which one to keep, which one to delete. Okay, and therefore even to decide upon which one to delete and which one to keep, you need to do some kind of a churning, and to do this churning you might require big data tools. Okay, therefore veracity can lead to big data. There could be other examples such that you had some data, you cleaned it, and you prepared some sort of statistics on top of it. Now this statistics might itself be a big data. Now you have two sets of data, the original one and the processed one. Now the question remains, should we keep one or should we keep both? Okay, so because of these doubts or confusions, you generally end up having multiple kind of data sets for a single data. All right. Madhi's question is, what is another V? V for value we talked about. I'll not like to discuss that part, okay, because I find it redundant. Shivam's question is, what is the data collected that is so big in size? Okay, so the data collected could be of various form, could be something like the logs of your website. The data collected could be your photographs, could be your videos, the videos which we are discussing right now, that is getting recorded. So data could be any form. All right, Mayur and Vidhi, were you able to understand the difference of understand what is veracity? Asutos's question is, what is the difference between veracity and variety? Veracity leads to volume, okay, while variety means that you have different kind of problems to solve, and by virtue of different kind of problems or different kind of data to process, even the small volume can lead to a situation where your usual tool cannot solve the problem. Great. Moving on. All right. So a quick question to all of you. How many bytes are there in a petabyte? Quickly. Okay. Ravikant says 10 to the power 12. Akshay says 10 to the power 15. All right. Vidhi says a million gigabyte. Okay, that makes sense. All right, great. So all of you have answered that. And yes, Murli, you have a question. You have raised the hand. All right, great. So almost all of you have answered that. Yes. So it is around 10 to the power 15 bytes in a petabyte. So what does it mean by a bit or a byte? A bit basically can store information about a single toggle, as in a switch. The switch you have at home stores a single bit of information, whether it is on or off. Similarly, a single bit can store 0 or 1, and therefore can be used in conjunction with another bits to store big numbers. So 1 byte can store 8 bits and hence can store 256 states. Okay? And a kilobyte is 1024 bytes, megabyte is 1024 kilobytes, and so on. And this way you can remember the bytes. Now, all right, the bigger question here is petabyte a big data? So we talked about big data. Big data was something for to process that kind of data you required kind of distributed computing, and a petabyte data is 10 to the power 15 10 to the power 15 bytes. Okay, now question is is 1 petabyte big data? And when I say 1 petabyte, let me put it the other way. What do I want to do with this 1 petabyte data? What I want to do with 1 petabyte data is to store it, and maybe at the end of every day, I want to count number of characters in 1 petabyte data. Now, can your existing usual tool solve this problem? Okay, let's say in 1 petabyte of data every evening, I want to just compute number of vowels in it. Okay, all right. So Lokesh's question is yes for smaller company, but can be managed with distributed SQL servers. Yeah, and Akshay is saying depends on the processing architecture. All right. So any other? So the kind of problem I'm telling, so you have 1 petabyte of data. Do you think it is big data? Meaning, can't your existing tool solve 1 petabyte of processing or 1 petabyte of storage? Anyone? So Ravikant is saying that even word count will take hours. So answer is yes. Vidhi's point is that if it's unstructured data, then we have to count it as big data. So Pranay's question is, what is the question again? So is 1 petabyte big data? That's my question. Veena is saying it might take too long to process in traditional way, so we need big data. Okay, right, good. So yes, most of the existing systems cannot handle it, and even if existing systems we try to build it, and the say we are using distributed SQL servers to manage it somehow, you will end up building a big data solutions. Okay. Now, another question to all of you. You have 1 terabyte data. How much time do you think it will take to read 1 terabyte data? We don't want to process, we just want to read it and just abandon it. Okay? Anybody? We are talking about 1 terabyte, not even 1 petabyte. Shivam says an hour maybe. And we are talking about the usual hard disk drive. Correct. It takes around somewhere between 3 to 6 hours. For some systems, it might take 3 hours when they are using a good hard disk, and some systems it might take 3 hours. Okay, so 3 to 6 hours it will take. Now, you can imagine when we say petabyte data, if we have to read a petabyte data, it will take 3,000 hours to read from a single drive if you have 1 petabyte hard disk. Therefore, no matter which computer you use, whether you are using P4, Core 2 Duo, 10, 10 cores or 100 cores, it doesn't matter. It will still take 6 hours to read 1 terabyte data. Okay, you can bring down 6 hours to 2 hours or 3 hours by buying really, really costly hard drives, but you cannot bring it down below 3 hours on a usual hard drive, on a even a costly hard drive. So the question is, when handling such kind of data, neither neither our RAM or nor our hard disk nor our processor upgradation is going to help. If that is the situation, what am I going to do? How do we solve this kind of problem? And that's where the big data solutions come into picture. Correct, Ravikant. The bottleneck is hard disk speed and not the CPU speed. Doesn't matter which, whether you are using a supercomputer or you are using a quantum computer, if your data read speed is this much, y- n- then your CPU actually will be 0% used and will be fairly free. Okay? So, okay. Yes, SSD can help by improving it by 10 times. Okay? That means it will, if you are using SSD maybe 20 times, it might take 10 minutes to read from 1 terabyte data. That's correct, Satya. This is based on IO IO operations of hard disk. Yes. Thank you, Lokesh. It's the RPM of hard drive and the cache size of the disk that matters. That's correct. Great. So this is another traditional chart which shows that the global information storage capacity has increased tremendously when we talk about digital storage, while the analog storage hasn't changed much. And the biggest change started in 2002, where the data suddenly started increasing exponentially. Okay. Now the reason for this explosion of data, as we told that since 2002 the age started. Why do we call so? The reason is twofold. First, the smartphone, meaning the hardware. Second is the connectivity. Hardware means that all the devices became smaller, faster, and cheaper. Okay, and that, I mean, the phone you hold in your hand is actually the acme of the engineering. Okay, it has, I mean, every year and year it has become faster, cheaper, and smaller. And since 2002, these phones, the smartphone came into realization. And other than that, the connectivity became really really well. So while on one hand you have got these devices which can generate a lot of data, every phone can generate a lot of data in the form of photos, in the form of audios, in the form of video, in the form of um, sensors. It has and the call records. So it can do a lot of things. It can generate a lot of data. And on another hand, when the connectivity became really good, the data transmission became became really high, and therefore the data duplication became really high. For example, right now when I'm delivering this, it's getting a single byte is becoming 60 bytes. Okay, why? Because it's getting transferred. So you can think of transmission always as the duplication of the data. And therefore while on one hand we have great smartphones, on other hand we have the we have a great bandwidth, and therefore the data explosion started. Okay, and to basically utilize these two things, we got softwares which, such as Facebook, YouTube, and other things, which generate a lot of data, which capture and generate a lot of data. All right. Now, Question is, which components do you think impact the computing? Anybody? Yes, all of these components actually impact the computing. Okay, it's not the CPU alone. The way we have been sold the Pentium or P4 or various kinds of processors is as if if you have a great CPU that will solve our problem. No, unless you have other components also of the higher configuration. Okay, so it's not alone the CPU, it's also the memory as in size as well as the speed read and write speed of the memory. Similarly, disk size and speed. Then how fast can your device read from the network and write to the network? Okay, so all of these are basically okay. So we have already talked about it. All right. So all of the components were uh, play a very vital role in the computing. Whenever we say handle the data, any of these components would be, I mean, all of these components would be required. Okay, and broadly we say that these are the four things that are required for computing, although the whole computer is required for the computing, but these are the general four components which become the bottleneck. It could be the network, it could be the disk, it could be CPU, it could be RAM. So any of these four things could become the bottleneck, and therefore sometimes it's not possible to upgrade a system and solve the problem. Imagine that if you if your CPU was becoming a bottleneck, you will increase the CPU. After some time, your RAM will become the bottleneck, and most of the time you cannot upgrade the RAM. You cannot upgrade the RAM beyond 200 GB. Okay, I mean, I've never seen a system having more than 200 GB RAM. Okay, and it's very costly. Second is, even if you increase the RAM, disk read write will still be very slow. As we told you that disk read write is actually a big bottleneck, right? And then other bottleneck is your network card. Okay, if you try to solve the disk read write speed by putting then putting the machines in the network, then your network will become the bottleneck. Okay, if so when you try to solve any of these problems, the other components will start becoming the bottleneck, and you will have no choice. If you are going to handle big data, you will have no choice at a point of time than going for a distributed computing platform. Okay, because at least one of these things will become the bottleneck. All right. So Vina's question is, so what components are we changing in big data? In case of big data, we do not change the component. Instead, we buy a newer computer, connect into the network, and distribute the load. Okay. So and when we buy a new computer, we are actually buying a new CPU, new RAM, new network, and new disk. So we got four things instead of only one thing upgraded. All right. So when we deal with big data, we deal with distributed computing. That's what we have discussed so far. Okay. And that's how we are defining big data, meaning a- as we have progressed, we have started accumulating lot and lot of data, and we have the demand to process bigger data, and therefore to handle data beyond certain size, beyond we generally hit a bottleneck with respect to any of the four components we discussed, and hence we go for a distributed solution. Okay, now you might say that what kind of problems are we trying to solve? How will it help to store such a data? In simple words, in simple words, when you have big data, you have bigger truth. Okay, if you have small data, you have smaller truth. All right, and therefore, bigger the data, better it is for lots of cases. Okay, because sampling the data and coming to the conclusion is not that accurate, and therefore you need to generally handle big data to come to insights which are really useful. Let's take a case of e-commerce. In case of e-commerce, we build recommendation engine. So at Amazon, their maximum sale happened because of great recommendations. Okay, and the recommendations happen because they have humongous data about the users. So the more the data, the more people are visiting their websites and more data they are recording, the better will be the results. Okay, better will be the recommendation. If you have smaller data, you have say 10 people visited your website and you're trying to display the recommendation, your recommendations will not be that great. Okay, your recommendation will not be that great. But if you have a million users, the recommendations that you will generate will be really great. Okay, so recommendation engine was probably the first big use case of big data, other than storing the crawling crawl data from the world wide web. Next was the search quality. You want to improve the search quality of any of the tool, then you will need to download a lot of dictionaries and you need to understand a lot of data, and therefore the big data will be helpful to you. Okay, then third one is sentiment analysis. We'll show you sentiment analysis in a while. And so Ravikant's question is, before we move forward, that so we are talking about commodity hardware. Yes, we are talking about commodity hardware. We are not upgrading the existing computer with hundreds of GBs of RAM. Instead, we are adding more computers to the network to solve our problem. And those are called big data platforms. Okay. So Veena's question is, what does it mean by distribute the load? Distribute the load can be in any form. Instead of storing all of the data on one computer, we distribute the data amongst multiple computers. Okay, some few GB is one, few GB is another, and so on. All right, great. Now this is called recommendation. Recommendation can be as simple as that people who bought this also bought these products. Or recommendation could be, so this is like first form of recommendation is based on the past history of people. We are telling that this is what people other people bought. Second one is curated partly, where we say that people bought these things together. Third kind of recommendation, you can see that based on your past history, you have got these recommendations. Okay. So based on your past history, how which movie have you rated how, and it has given you the recommendation. So these are the kind of recommendation, and these big data platform try to give you the recommendation really well. Okay. For example, let's take a case of Mahat. Mahat is a tool which runs on top of Hadoop. Okay, so just think about, there is some tool called Mahat which can give you the recommendation really well on humongous data. Okay, and all it requires is that you give it uh, the three column data, as in product ID, user ID, and how much this user has voted this product. Okay, based on just alone this data, the kind of tool we are talking here, the tool like Mahat can generate brilliant recommendation. Okay, so l- lots of these tools basically run on top of big data platforms and give you the result very, very fast. If you try to run the similar recommendation on big data on a single computer, it may not be physically possible. Okay, so this is how. So Ravikant's question is, just out of curiosity, how many machines companies like Amazon would be using to process such data? Okay, so there are thousands of machines to do thousands of different kind of things. Okay, so for example, I was doing the processing of the image that is displayed on Amazon's website, the product image. When you see a product, the default image that is displayed there, we had to optimize and process that image. For that, we were using close to 60 machines. Okay, and that happens all the time. All right. Next is the sentiment analysis. So I'm trying to explain to you what does it mean by recommendation and what does it mean by sentiment analysis. So recommendation is, given your history of choice, we can recommend you something which is which is basically something which you may like. Okay, great, great. So moving on. All right, keep your questions coming. Any questions still here till the recommendation? So far, what we have talked about is that when the data grows bigger beyond the size and the kind of problem you're trying to solve, if you're not able to solve that problem in a reasonable time on a single machine, you move on to the big data solutions. And the examples of big data solutions, the big data problem you might like to solve on these kind of platform would be maybe recommendation engine. These are the few example use case. Okay, there are every day I see all kind of new use case people are coming up and they are using it in their organization. Okay, because just now they have realized that they can actually economically store humongous data without any problems. All right. Next is the sentiment analysis. Sentiment analysis, as in, what are people talking about your brand, your product, or your organization in the open world? Whether people are talking negative about you, positive about you, quantifying that sentiment is sentiment analysis. Okay. Sentiment analysis could be as simple as going through the Twitter and understanding how many negative keywords are used against your brand name, and also understanding how many positive keywords are used against your brand name. Or sentiment analysis could be as complex as understanding the natural language, understanding English, and deducing the meaning of the sentence. All right, that is also a sort of a sentiment analysis. So the sentiment analysis, when you do, you have large number of data coming in per second, and hence to handle that kind of large data, you require a platform which can run parallelly on multiple machine and solve your problem. So other big data customers could be government. Other big data customer could be government. And government uses big data for lots of different reasons: for fraud detection, cybersecurity, welfare, justice system. Similarly, in healthcare and life sciences, almost every data is big data. And they don't have any other other solution than using big data solutions in order to churn. Okay, when you have terabytes of samples or of information, you have to process that. Then probably the most reasonable thing to do is using Hadoop and or any other big data solution to solve your problem. Yes, thank you, Ravikant. Aadhaar was a very good example of big data, and their big data solutions were used. So Veena is saying, so how long does a company like Amazon store purchase history from users to give recommendation? Okay. So first we store the purchase history of everyone forever. Okay. And the recommendations are generated on various criteria. For some product, the we consider only recent data. For some product, we consider the full data. Okay, so that's a complex mixture of things. There is no straight answer to how long do we consider, how old data do we consider for recommendation. Okay, for example, the recommender which I built, we were just considering around last 4 months data, but then we realized that 4 months data was not sufficient for some products. So after we have processed and cleanly decided, then we did a second phase of eliminating the older products, which were, for some products it doesn't make sense to keep the older data. Okay, but we generally tend to keep as much data as possible. Let the model decide which one to keep, which one to remove. Okay, all right. Now, and there are many more companies who are using big data as of today. This is like pretty old slide. So here it shows that Yahoo is the biggest user, but nowadays probably lot of companies have come up who are using big data in their solutions. And probably every company has to inevitably move, every organization have to inevitably move to big data platform, because the storage becomes suddenly really cheap if you move to big data solution, because you are utilizing multiple smaller hard disks rather than buying very premium hard disks. Okay, so suddenly when you start using a big data platform, suddenly your storage becomes really cheap. Okay, so therefore every organization will inevitably move to big data, big data platform and big data solutions. And other reason is when the storage becomes cheap, and the tendency to store the data becomes really high, and therefore to process that kind of data, every organization will have to employ big data solutions. Therefore, it makes a lot of sense for all of us to understand how, when, and why to use big data, and what are the various tools, and understand it. So this is just the beginning. As of today, there are lots of organizations are moving on to big data for various reasons. Okay. So what does Venugopal is saying, that what does it mean by model, when I said that we leave it to the model whether to keep a particular data or not keep a particular data. So we leave it to, the recommender, the algorithm, the data model, whether some amount of information is useful or useless. Instead of we upfront deciding that, hey, we will keep only last 10 days data to decide upon recommendation, Instead, we say that we have past 1 year's data. Now we'll process it, we'll clean it, and we'll form the correlation groups, and then we will decide which data is useless, which product history is no longer valid, or which product history is valid. Okay, so instead of upfront deleting the older history, we keep the whole history of the users forever, and we do not take the judgmental call that we don't require a particular piece of data about user. All right. Pranay's question is, what does Google use? Google has their internal tools, and the tools which we are going to use, that is Hadoop, is based on actually the Google's tools. Google published some tools, and based on that, these tools have been designed. Okay. All right. Here are few myths which I keep hearing all the time. So I've just listed these myths. So first myth is big data always means data above or in the range of terabytes. No. Okay. So there are situations where even 100 GB of data becomes such a big data that you have to inevitably move to distributed computing. Okay. As in case of velocity and variety, the volume may be smaller, but still you would require distributed computing. So big data is always about social media and doesn't apply to me. Social media happens to have the biggest data storage in the beginning, but nowadays even the pharma companies, telecom companies, banking organizations, everybody has realized that there is a lot of data they can store at economical prices, and there is a lot of computing they can do at a very reasonable price, and that's why it applies to probably all of us. All right. Okay, so we have yeah, I think, thank you Suresh. Now going back, yeah, we missed A B testing. Okay, so I think a best way to understand A B testing okay is that, so when a drug is tested, it is given to different set of users. Okay, we basically give to two set of users, one without the drug, one with the drug. Okay, we give two samples, and we observe the behavior of both the data sets, and then do the analysis. Okay, and so in on the similar line, companies like Amazon and companies like Google, what they have done is they have created A/B testing for their product launches. The way in industry, the way in pharma industry we have drug testing, in the same way, before launching a product or before changing a feature, we basically s- show the feature only to say 0.01% of the user or 0.1% of the user, and then understand whether the user actually was benefited or not, or how much did the sale happen when we changed the buy now button to say blue. Okay, on Amazon website there's a button called buy now. Now if you came up with an idea, say you want to change this color of buy now button to something else, instead of just changing it and believing you that it will work, the way it is done is we'll change this color to for only few users, meaning we launch a new buy now button, and for that new button we'll just send the 1% traffic to it, and thereby testing whether your hypothesis is correct or wrong. Okay, by analyzing the data in real life, that is called A/B testing. Now in a company like Amazon, or in a company like Google, or in a way is other companies also, if company is really serious about improving products, every product will be running its own variations. Okay, therefore, on a website, there will be a permutation of maybe thousands or maybe a million permutations being displayed parallelly to various users. And therefore, A B testing leads to a lot of handling of complex structure of the data. All right. Suresh, was I able to explain? Okay. Beta testing is different. Beta testing is like before product launches, you have few beta users, you just showing them. No. Here what we're talking about in the production. In the production, only few set of users are seeing this new feature. So Veena's question is big data cheaper? Why only big companies are moving to it? So big data is cheaper comparatively with respect to cost of hardware. It's just the experts are not available as of today. So few experts are costing too much. And therefore, therefore there is a huge demand of experts in the domain. Okay. And that is the reason why smaller players are not venturing into it. Okay. So there is no full form of A/B testing. A/B means we just name the actual one as A and B as the new product, and that's all. There is no full form of this one, or maybe I don't know, but there is no full form I've known so far. Okay. Next myth I keep on hearing, it will replace EDW. No. Enterprise data warehousing will exist in the current form because there's a lot of data where big data tools cannot solve the problems. Specifically when it comes to transactions, almost all of the big data, since they run on multiple systems parallelly, they are not able to provide you that strong transactions. And therefore, EDW will keep playing the role in case of transactional data, where you require transactions. It is just buzzword, no practical application. So this is one technology. There are lots of practical application, and every now and then, every company is moving into that direction. It's a new concept. No, it's a fairly old concept. As I was telling you, at DE Shaw, we used to call it grid computing. Okay, we used to call it grid computing. Now it's called as big data. It will be the future. No, it is the present. Is expensive? No. Almost all the tools are very uh, almost every tool in the big data world is actually open source. Okay, almost every tool, and is expen so the only expensive part is the vendors or the people who are providing the consulting or the services in big data domain. Is only for data scientists or is a magic? No. Big data as a whole, so data scientists just do a small 1% of the work. There's a lot of different kind of work that are done on big data, just like on the normal data. Okay. So we have enough hardware, does not need more. Big data does not mean hardware. Big data means that whatever hardware you already have, you can put it to use, a proper use, using the new architecture. Now, we will build it when we need it. That is another myth, because the thing is that lots of organizations live in this theory that we will build it when we need it. The thing is, the need of storage is always there in an organization. It's just that because storage is not there, lots of people are not storing the data, and thereby they do not feel that they require bigger storage. Okay. And so this is another myth. I keep on seeing it all the time, that we will build it when we need it. But the thing is, everybody need to start storing the information about their users so that tomorrow they can do an analytics. Okay. So it's a part of planning. Big data is about Hadoop. No, there are many solutions which cater to big data, not only Hadoop. It just so happens that in case of Hadoop, there are a lot of great there's a lot of great innovations have happened. There are a lot of products which are lying under Hadoop umbrella, and therefore Hadoop is actually a full complete solution, while there are many solutions which are under the umbrella of big data. Okay. And with respect to salary trends, I've added this slide. You can also look at indeed.com. Okay. So far, Hadoop has got the best trend out of all the jobs. So you can take a look at that. All right. So let's take a break for 10 minutes. Okay. Let's take a break for 10 minutes and then we'll continue the discussion. So we will be back by 9:43 p.m. IST. Okay. All right, so I think we should start now. All right. So, in the first half, we talked about big data, and there are multiple solutions. So, here are some of the solutions. Okay. And this is not essentially complete, it's just a few examples I'm giving here. First one is Apache Hadoop, that is one solution. A solution, when I say solution to your big data problems. Okay. So, Hadoop we will discuss anyway. So let's discuss about some other aspects. So we have Spark. Spark only provides you the computing engine and is actually now lies under the same umbrella as Hadoop. Okay, so it's actually redundant to list Spark. Then is Cassandra. Cassandra is one database which provide you the storage for structured data. Okay, if you have a lot of unstructured data also you can store in Cassandra, but Cassandra does not provide you various kinds of libraries or algorithms f- for machine learning or anything. Cassandra is just a database where you can store data in the structured or unstructured format, and then you can process it. And but for processing they provide you the MapReduce engine, but it doesn't have that big support for processing as compared to Hadoop. Similar is the case with MongoDB. In MongoDB you can also store anything, whether structured or unstructured data. Okay, and when you say unstructured, it means that the data with a single column, and that's all. Okay, so you can do that in case of MongoDB as well, meaning you can store files in the MongoDB. But again, it doesn't have that great support for processing the data. It provides you usual joins, where clause, filter clause, but it doesn't provide you the library like recommender, like Mahoth. Okay, so in case you don't require the machine learning or statistics on top of your data, then you don't require any other solution. You can go ahead with Cassandra or MongoDB. Okay, uh, then is the solution like Azure or Elastic Computing from Amazon or Google Compute Engine. All of these solutions from Amazon, Microsoft, and Google, these solutions provide you a remote place to upload your data, meaning their cloud. When I say cloud, cloud is nothing but a computer at some other place. Okay, a remote computer, and so you can upload your data into Google's cloud, and then you can start churning the data. Okay, so these are the various solutions which are available as of today. So based on your requirement, you can pick up anything, but probably the wisest thing out of all of this is to go with Hadoop, because that is probably the most complete solution. And it actually, Hadoop provides a database like Cassandra in the with the name called HBase. Okay, Hadoop also the Spark is a part of Hadoop, and Hadoop provides you all kind of tools and techniques to do import, export, processing using SQL, doing various kinds of algorithm like machine learning, recommendation, sentiment analysis. All of these are part of Hadoop. Contains libraries for all of this. All right, so it's actually a wise decision to go with Hadoop. All right, now Satya's question is, how do we run open source tool on Windows Platform Server? Windows Platform Server run Java. So all of these, and Hadoop is written in Java, so it runs on Microsoft's platform. Okay. All right. So we will be focusing on Hadoop. Hadoop was created by Doug Cutting and Mike Caffarella. That time they were working at Yahoo, and basically, they were trying to write their Nudge search engine, their own search engine called Nudge. For that, they had hit the bottleneck of the file system as well as the bottleneck of the existing database. And luckily, at the same time, Google released these three papers. First was Google File System. Other technical paper was Google MapReduce, and third one was Google Bigtable. Based on these three papers, Hadoop guys wrote, Mike Caffarella and Dog Cutting wrote Hadoop, these solutions for their own search engine that became Hadoop. Hadoop was named after a toy elephant, a small toy elephant, and the license of Hadoop is Apache, and probably that is one big reason why Hadoop has been so successful, because Apache license is the most liberal license, and and it doesn't put any kind of a restrictions on organizations. So whether you want to use Apache Hadoop for your own purpose or for your company purpose, education, NGO, anything, it's absolutely free. Okay. And in case you want to bundle any of the Hadoop products or Apache licensed products inside your own product, then Hadoop doesn't restrict you or Apache doesn't restrict you. That is the beauty of the license. Hadoop is powerful, is popular, and is well supported. It's a framework to handle big data, meaning all the components under the Hadoop umbrella are for reliable, scalable, and distributed computing. Reliable means in case one machine fails, the work gets done on another machine. Scalable, if you are running your system of using 100 computers and you want to add 50 more computers, it should just all the software which is lying under a Hadoop umbrella should automatically scale to fit onto 150 systems. Distributed means anything you want to get done should get done on these 150 computers parallelly, or some of the 150 computers will be utilized to solve your problem. So all of the components under the umbrella of Hadoop have these properties. Also, Hadoop is written in Java, but that does not mean to operate Hadoop, to utilize Hadoop, you require Java. Okay. All right. Now, before I move forward, let me just first answer your question. And Shivam's question is MongoDB is only for storage. MongoDB is good for storage, plus it has got the various kind of query, the aggregations and map reduces. Okay, but it doesn't have that sophisticated library of algorithms for as compared to Hadoop's Mahout or MLlib's Spark's MLlib. Okay, so it's good for storage and doing the rudimentary processing. Okay, now is there any programming interface provided? So when we say programming interface, probably I'm assuming that you are talking about database called HBase under Hadoop, right? So yes, so in those cases, Hadoop HDFS does provide the JDBC kind of interface so that you can connect to these databases using JDBC. Similar is another tool under Hadoop umbrella called Hive that also provides you a JDBC interface. So again, let me emphasize again, Hadoop is not a single component. Hadoop is these many components. All right. And there is one more component which is missing here called Zookeeper. Okay, so we will be talking about all these components in this session. Okay, all right. Now, Shivam's follow-up question is, how can we process the data stored in MongoDB? So MongoDB does provide you the query language, okay, in the form of aggregations. You can have a look at one of the videos I have uploaded on the YouTube channel. in which I demonstrate how to use aggregation and how to use MapReduce that would answer your query. All right. Now there was one question which I missed. Why why IoT is referenced along with big data? The reason is that, as I told you, that while why big data now, I talked about two things. One is devices. Devices have become smaller, cheaper, and faster, and other was the network, right? So IoT has to do with both, as in you design new devices which can generate a lot of data. And to handle this kind of data on the server side, you need to have some kind of a big data architecture to handle or store that kind of data being generated by IoT devices. All right? Most of the IoT devices generate data. Only then they do the really useful part. Okay? So Shivam's further question is Hadoop and MongoDB are locally stored on our server? No. Okay. MongoDB is also distributed. Hadoop is also distributed. Vivek's question is why pig? Why the name? It's just the name. Okay. It's just the name. They just kept the name. Okay. Okay. So when you read about the philosophy of pig, that pig eats anything, pig is a domestic animal, then you will understand why they named pig. All right. Can we use a combination of big data tools based on their strength? Definitely. That is the way forward. Okay. So there is no one solution for all. As of today, there is no single solution for all kinds of problem. Unlike in olden times, we used to use RDBMS for all the solutions. Okay. But in this new era, the there is no single solution to solve all the problems. Although everybody is trying to do that, but still they are fairly unsuccessful. Okay. All right. Vina's question is that what is yarn? Just give me a second. I will explain. So again, Vivek's question is how security is handled in big data or Hadoop. Security is handled in the traditional manner, such as Kerberos. For example, Kerberos provides the single sign-on layer for a whole system. In the same fashion, the security is handled across all the components. All right. Okay, so what is NoSQL? Let me just describe it in a minute or so. Okay, just give me a second. All right, great. So let me describe one component at a time. So at the bottom you have something called Hadoop distributed file system. Hadoop distributed file system is probably the most basic component in the whole ecosystem. Okay. Hadoop distributed file system does not depend on any other than Zookeeper. So Zookeeper we'll discuss in the session number 9. So HDFS or Hadoop distributed file system stores files just like your normal FAT32 or Linux file system. And the way when you open the file browser you see C colon, D colon, and so on. In the similar fashion, Hadoop provides this Hadoop distributed file system. Okay. So, and Hadoop distributed file system is something on which everybody depends. Just like your MS SQL or MySQL stores their database file in somewhere in your local drive, in the similar manner, Hadoop databases such as HBase, okay, Hadoop databases such as HBase or maybe a query platform like Hive, they all store the data in HDFS. Similar is the compute engine. Compute engine performs the computing on top of this file system. Okay, and this file system is distributed in the sense that so, uh, so in the sense that some of your data will be on one machine, some will be another, some will be on another, and you would never have to worry about it. You will never know. You will never have to interact with the gory details. To you, HDFS will look like a C colon or E colon or D colon, a single file system in which you can store as much data as you wish, as much data as can fit into your whole cluster. Okay, so that is the main component called Hadoop distributed file system. If we have some time today, we will start HDFS. Okay, all right. Now, on the top of HDFS, you have something called yarn. What is yarn? Yarn is something which makes it possible to run any software near to the data. As I was telling you that HDFS runs on all the computers, meaning HDFS is spread across your network. So you have say 100 computers. All these 100 computers are participating in providing you the storage. So similarly, all these 100 computers will also participate in the computing. When you have a problem of computing, say you have to do something like counting numbers or counting the characters in the file system, you will have to delegate it to somebody like Yarn. Yarn runs on all the machines parallelly. So whenever you have to get something done, some computation done, you hand it over to Yarn. You give your logic, give your program to Yarn, and Yarn will execute parallelly on all the computers. Also, Yarn is not something with which you will interact. Yarn is more like a thin layer of, more like interface for other programs like MapReduce. Okay, so to do the computing on top of Yarn, you use tools like MapReduce or libraries like MapReduce and Spark. Spark basically uses Yarn to get the work done on the whole cluster. Okay, so you interact with the Spark, you interact with MapReduce, but you do not generally, as an end user, you do not generally directly interact with Yarn. Okay, so Yarn is that thin layer that gets your work done on the cluster. Okay, but the program which you will hand over to Yarn will be written by you. Okay, and because of Yarn, it is actually possible to write your own different kind of an application which exploits the distributiveness of Yarn as well as the file system to get your work done. Now there is a third. Uh, there could be many other solutions that could utilize Yarn, and probably Yarn is the reason as of today why Hadoop is not dead. Okay, yeah, because of the Yarn, Spark was able to be run on your existing Hadoop cluster. Okay, so feel free to keep asking question. I might be moving a little bit faster, so please feel free to stop me. And so, okay, let me answer a few questions before I move on to HBase. Or should I move on to HBase? I think there are few questions which are waiting there. So that was Vina's question. And all right. Earlier, the only before in Hadoop 1.0, you could only do MapReduce kind of computing on Hadoop. Okay, you can only the only way to do the computing was MapReduce. But because of Yarn, Hadoop made it possible to to separate MapReduce and the actual computing engine into two parts, and thus making a way for other tools like Spark and Tez, and there are many other components which have been ported to run on Yarn. Now there is a database called HBase. So HDFS is great when you have to store data in the form of big files. Okay, when you have to store files, you just dump it on HDFS. But if you have to store records, really huge records, then you use HBase. So most of the time you will be dealing with records instead of files, right? In those cases, you will be using HBase instead. Okay, HBase internally uses yarn for processing and uses HDFS for storage. So whatever data you store in the form of records in HBase, it indirectly stores it in the file internally, and those files are on HDFS. Make sense to you? Now, HBase is a NoSQL database. Again, there was somebody's question called what is NoSQL? So NoSQL is these new databases which are unable to provide you the transactional properties of database. Those databases, so HBase kind of HBase, Cassandra, MongoDB, all these databases run parallelly on multiple computers. Okay, so when you store something into table, some part of the table goes in one machine, some part of the table goes in another, some part of the table goes in any other. And so most of these NoSQL databases are distributed databases. Okay, and because of distributedness, most of these are not able to provide the relational properties of databases. Therefore, they choose to call themselves as NoSQL databases. All right. And now coming back to your other questions, Krishna's question is it possible to integrate big data tools? Yes. So these tools can be very well integrated. For example, how to integrate MongoDB and Hadoop. You can have a look at Mongo Hadoop. And there are similar integrations possible between Cassandra and Hadoop. And similarly, if you are writing something on Apache Hadoop, you can run the same thing on Amazon's Hadoop. Okay, so you can basically integrate multiple components with each other. All right. Coming to Vivek's question is only Kerberos or any other security like OpenSSO or OpenID. So it does provide you OpenSSO and OpenID. You can have a look. Okay, but OpenID or OpenSSO is not that exhaustive as Kerberos is because this is OS level. It is not only the OpenID kind of thing where you have Facebook and Google, they provide you authentication. No, Kerberos is far more exhaustive. Now, Vina's question is HDFS versus HBase. So it's a question like we have got some data. Should we store it as a file or should we store it as in the MySQL? Okay, so it's up to you. Okay, if you can answer that question, then you can also understand that HBase, whenever you want to deal in terms of records, if you want to uh, manipulate records, you want to update a record, you want to delete a record, you want to insert a record, then you go for HBase. If you want to deal with records, if you want to update, insert, delete, when you do a based manipulation, you go for HBase. While if you want to store a file, delete a file, and create a new file, then you or append to existing file, then you go for HDFS. Okay, Vina, was that okay? So Vivek's question is, so can't we control the space a specific data needs occupied, like table space in Oracle. No, I did not get your question. So can't we control the space a specified data needs occupied? I'm not sure what does table space mean in Oracle. Okay, so okay, but once you understand what does HBase do, you will be able to correlate. Okay, all right, all right, great. So Veena is saying, so HBase stores as records, so it's only for structured data. I would like to say that it is for semi-structured data. Okay. So you don't have to, like your usual database table, you do not have to describe and define the data type of each column. Each column can have different values and different data types. So that's a difference in HBase. So when you have to store semi-structured database and you have to do record-wise manipulation, then you go for HBase. So Akib's question is how difficult it is to opt for this architecture for an existing non-distributed architecture product. The answer is very difficult. Most of the distributed architecture project has to be architected again from the beginning. Okay, because the main paradigm changes, everything changes. Okay, so so you need to be aware of this fact that it's actually fairly difficult to just port the data, port an application to Hadoop. Okay, reason being that for storing the data, your strategy will change. For retrieving the data, your strategy will change. Your data models will change, and therefore your application will change. All right. Although it's a well coordinated effort which is going into making it such that as if it looks like that it's a central database. It's it they are all trying all of the technology is being used into making HBase or any of these tools like Hive look like the traditional database so that porting can become very easy. Very good question. And so Arun Kumar's question is, when I say I'm using Hadoop, does it mean I use all or many of these components, or the installation configuration is the multi-step process? So yeah, so it is, so most of the people who I have met, they'll be using only one part of the Hadoop. They'll not be using the full. Okay. And so it is that way. So if somebody is using Hadoop, you should ask like what is it that you are doing on Hadoop? And okay. So I hope I have answered your question, Arun. So Kirit's question is, what is the significance of Hadoop? Significance as in whenever you have humongous data and humongous processing to be done, you can't do it using your normal computer, then you opt for Hadoop. That is the significance. Okay. Mayur's question is, storing data is difficult or to retrieve? So so it all depends on which system are you using. In case of Hadoop, and for that matter, everywhere the optimization is done on retrieval of the data. Okay, so assuming almost all the systems are designed in order to such that your retrieval is faster than the writing. Okay, and that same is true in case of Hadoop. Take the case of HBase, take the case of HDFS, take the case of Zookeeper. So everywhere it is the you know the reading speed is a little bit faster than the writing speed. I hope that's what you meant, Mayur. Are these tools to export data from existing? Are there tools to export data from? So yeah. So I was coming to that one. So here you see that there are a tool called Scoop and there's a tool called Flume. If you have got a lot of unstructured data which is coming in very frequently, then you would like to go for Flume, which can copy the data continuously onto HDFS. And there is another data tools called Scoop. There's another tool called Scoop, which basically copies the structured data onto HDFS. Okay, meaning it takes the JDBC connection URL, connects to your existing database, copies whatever table you want from there to say HBase or Hive or normal as a file, as CSV file or tab separate file onto HDFS. That is the role of Scoop. So Veena, that was your question. All right. Now, Aparna's question is, where exactly does a scientist fit into big data picture? So mostly the data scientist's role is to come up with the insights into the data. Given a problem, given a business problem, a data scientist has to come up with an approach to solve it using the data. Okay, and and a data scientist might depend on developer, analyst, and other people who can give him the access to the data. Okay, okay. So Arun's question is, or in other words, all other components require Hadoop DFS being installed. Yes, HDFS, every component depends on HDFS, so Hadoop installation necessarily has to have HDFS. HDFS and Yarn and MapReduce is by default installed. Installing HBase, Hive, and Pig is optional. All right. Now, Gaurav's question is, what is an example of production level Hadoop deployment where total data size is less than 1 TB with very less velocity? What is the example of production level Hadoop deployment where total data size is less than 1 TB with very less velocity? So, I did not get your point. So, I mean, there are many systems which have lesser than 1 TB of storage, 1 TB of data, but those are in planning phase. They're designed such that a lot of people will be using this system. Okay, they are for the future cases that we are providing this place where all the developers, all the applications can store the data, and at a later point of time, various data analysts can look at this data and come up with various kinds of inferences, various kinds of useful uh, useful deductions. So for that purpose, even if your data is smaller as of now, you like to build a Hadoop cluster. Okay, was that your question, Gaurav? Now Ravi's question is, how easy it is to debug functionality in Hadoop? Okay, since Hadoop is like bunch of components which are running as services on the cluster. Okay, so the only way mostly to debug these applications is by the way of logs. Okay, you look at the logs and try to understand it. In case that doesn't suffice, you can actually execute program in isolation inside a virtual machine environment where you can stepwise debug. Okay, you can attach a uh, debug interface to via Eclipse to any of JVM, and then you can debug the application stepwise. Okay, so those are the debug functionalities. So now Vidhi's question is, in existing application, how Hadoop can be introduced? Okay. Can we start using few components of Hadoop in beginning stage? Yes, of course. So in the existing application, how Hadoop can be introduced? Yes. So in say your existing application is using a database and a file system. So that can be generally easily switched. You can easily switch it by instead of connecting to the normal file system, you start connecting to HDFS and you start using the ADBC driver for HBase. Okay. But generally, that's just very suboptimal. You have to always come up with your big data solution, keeping the big data in mind. Okay. Now, Veena's question is, what is Zookeeper? Zookeeper is a database, is kind of a very small database which runs on top of the whole cluster. Using Zookeeper, you can make it. You can using Zookeeper, you basically coordinate amongst other systems. Okay, so you will understand once you understand HDFS and HBase. So Zookeeper is a very small database designed for coordination between big data services. All right. Now, Akib's question is there any standard cycle approach? If yes, is it possible to implement DevOps concept on top of it to increase the velocity of the cycle? Okay, so DevOps are actually in place. Okay, but I think your definition of the terms is very different from what I understand. So developer operations is basically always there as if it's just another system. Okay, so your general development cycles are not changed because of tool changes. It's a practice which your organization follow. Okay. If you are going for big data or Hadoop, you're not really going to change your SDLC approach. The same SDLC approach will remain in the new world as well. All right. Okay. So your SDLC approach, your software development lifecycle approach will remain intact. Whatever you had been following, you follow that one, and I mean in the same way you align the services and systems. Okay. So I hope I'm able to answer Akib. All right, so we discussed about HDFS, we discussed about yarn, MapReduce. We just described them in one phrases, and we also talked about Flume and Scoop. Now, when we churning data using yarn, you will have to write a very exhaustive uh, program saying do this on first machine, do this on second machine, and so on. Okay, so to make that simple, there is MapReduce where you just write how to group your data on what basis data need to be churned. Now, but again, MapReduce requires a little bit of programming, be it in any programming language, but it requires programming. Now, to avoid programming so that for small problems you should not need to write so much of code in MapReduce, people came up with things like Hive and Pig. You write your query language as if you are in a typical SQL. Instead of writing code, you write SQL, and that gets converted internally into MapReduce. So that is the role of Hive. Hive takes the query in the form of SQL, can converts it into automatically it converts it into MapReduces and gives you the result. And Hive is exhaustively used in churning the data in big data environment. Okay, so if you are good with SQL and you have understood the basics of SDFS and understood the basics of Yarn, then you are good to go with respect to analyzing data using SQL. Okay, you will only use MapReduce in the cases where SQL is not sufficing for you. All right, now while Hive was written in keep in mind the various DBAs who are very comfortable with SQL, various systems which have already written so much of scripts and queries in in SQL. So, but Hive was not as optimal as needed. Okay, therefore, people designed something called Pig or Pig Latin. Using Pig Latin, similar to SQL, you write your statements with where clause, with filter clause, with join clause, with group by, and all that. Okay, but in case of Pig Latin, the efficiency is little bit more controllable. Okay, you control your efficiency a little bit more, meaning you can specify various kinds of operations in far better form than Hive, and thus your Pig Latin queries will be faster than Hive. The other reason you would like to use Pig Latin would be for churning semi-structured data. Okay, in case of Hive, you have to upfront define each and every column of the data, while in case of Pig, you can choose not to define. Okay, so this way Pig will act like Pig will also help you in doing the ETL. Okay, Pig will also help you doing the ETL because it's okay with Pig to even load the unstructured data. All right, now Ravi Kumar's question is, can we create APIs? Okay, so it all depends what exactly do you want to do. Okay, APIs you will be creating in your traditional systems, whatever you had been using, and then those APIs would be interacting with these components. All right, so those APIs will be interacting with these components. Make sense to you? All right, now coming back to this. Yeah, so we have Hive, Pig Latin, and then we have Mahoth. Mahoth is basically a collection of algorithms. So most of your data churning can be done using Hive and Pig Latin, but there are some algorithms, say for example recommendation, for example doing various kinds of machine learning things, data sciences things. You cannot use Hive or Pig directly. There are a lot of work that cannot be done using SQL queries. And that's where the Mahoth comes into play. So when you have to do the machine learning, you use Mahoth. And if you are using Spark, you will use another library called MLlib. All right. Then you have Uzi. Uzi is a workflow engine. So when you will build a big application, you will be using HDFS. Maybe you have first import using a scoop, then you have some code in MapReduce, some code in Hive, some code in Pig Latin, so and then some code in Mahoth for some commands for Mahoth. And to execute all of this in a particular sequence, meaning first import the data, then churn the data using Pig Latin, then further do some processing using Hive, and then hand it over to Mahoth, let the recommendation come in. Once Mahad finishes the work, put the data back into your traditional database. So if you have these kind of flows, it makes sense to have a workflow engine like Oozie, which basically sequences all of this. Okay, so using Oozie, you can create the full, workflow of your scripts, and in what order, in what dependency these things should be executed. So that is the role of Oozie. Okay, you can interact with all of these services either using Java API, using command line interface, or using Python programs. In whatever way you want to call them, you can connect with them. Okay. All right. So Vina's question is, what is the role of Hadoop developer? So the example I just provided you, all of this falls under the role of Hadoop developer. Now Ravi's question is, if required, how Hadoop system communication happen? Uh, what was the question, Ravi? If required, how Hadoop to Hadoop system communication happen? Which tool is used? So, I mean, inside Hadoop you want to talk about, or outside Hadoop? There is another Hadoop installation you want to communicate. So yeah, in those cases you can simply use things like Scoop and Flume to export import the data, as well as say your some program is here, some, and you want to connect to another Hadoop, you can connect to another Hadoop using MapReduce. Okay, for all of that there is an API available. Okay, sounds good to you? All right, so we have some half an hour left yet. So we will get into the details of HDFS. All right, and we'll describe our other things later. All right. Okay. So we will discuss now the HDFS, probably a very important component, and that should also give you an idea about how the things are different in this new world. Okay. Let's say you have got 100 terabytes of data. How would you store it? Imagine that you are living in a hostel, uh, and you decide to store all of your movies in a centralized environment. How will you store this 100 terabyte data? Yes? Anyone? Okay. So Sivam is suggesting LAN server, while Ravi is saying that we can use distributed. Okay. We'll move to distributed before we understand how would you traditionally do it. Okay. Akshay is saying distribute it on everyone's computer. Yes, that is good. Okay. Revati is saying distribute across multiple servers based on geography. Good, good. Keep going. Okay. Vivek is suggesting that we should go for network file storage, NFS. Mayur is saying store with hierarchical manner. Yes, more details, please, Mayur. You are on the right side. Okay. Okay. So, yeah. So, Revati has suggested that we should distribute the data across multiple machines based on geography or any other relevant data on the other user want to distribute the data. So, for everyone, so that is called we call it, there is a good term for it. There is a This is called sharding. We slice the data such that some data goes to one machine, some goes to another, some goes to another. But such systems basically do not generally end up having the equal amount of load on one machine and another. Okay, there's always a manual intervention required. Okay. And Joseph's point is that store the data on different server alphabetically. Great, great. So probably all of you have suggested this kind of a solution. So you build a network attached storage or storage area network, that is NAS or SAN. Imagine that you bought 100 1 terabyte hard disks, and what you did with these hard disks, you basically connected these hard disks in multiple computers. Say you bought 50 computers, you put two hard disks in each of the computers, and then connected those 50 computers in the network such that these hard disks are available in the network. Okay. Now what you did was you did the mounting. You created 100 folders on one machine, and to to each folder you mapped to each hard drive. Okay, such that when you open up this main folder, you see these folders, and when you try to access these folders, you are actually accessing the actual drive. And then once you have created this folder structure, now you can form a strategy saying all the movies or all the files starting with A should go to the first folder, all the movies or files starting with B should go into the second folder, that is drive 2, and so on. Okay, so now it sounds like a very good solution, but do you think that there are challenges with this kind of approach? So is this approach clear to you, right? So is this approach clear to everyone? Garud, Vivek, Ram, Larry, Gaurav, Mayur, Raghavendra, Miguel, Venugopal, Madhi, Ravi Killer, Arun Kumar, Ashutosh, Chintan, Ram Nayak. Okay, so all right, Anagi, Pranay, Joseph, Jasmeet, Devi, Aparna, Saifur, Sruo, Amy, Akshay, Kenneth, Kirit, Sai Kiran, Vivek, Varda, Aman, Spandan, Ryan, Revati, Harsha, Sanjay, Vadhi, Ajay, Vijay, Krishna, Veena, Suresh, Shivam, Christian, Ziao. So, all right. So, is it clear to everyone? Yes, Vivek. Yeah, Vivek's question is, and multiple hierarchies are supported. It is up to you how you want to build that multiple hierarchies because you can map these folders. So now, so this is not a solution. It is just your solution, what you have just given. This is not HDFS. What I'm asking that, do you see any challenges with this? One challenge which uh, somebody has mentioned, Ravi has mentioned that change will be difficult. Okay, change will be difficult. That is correct, Ravi. So, any other challenge? Yes. So, Veena is saying there is no backup. Okay. So, Veena, will that be sufficient if we just provide one more hard disk into the same computer and put a uh, RAID kind of backup? Now, Madhi's question is, how do we handle scalability? Thank you. Good. So here, if you today you have 100 terabyte requirement, tomorrow you might have more requirements. Good. Similarly, Ravi's next point is that addition deletion disturbs the structure or hierarchy. Good. Now, Spandan's question is, indexing itself will be difficult in individual folder giving the amount of data. Good. All right. Other challenges will be hotspot for the data. Good. Cross-referencing of the data will become difficult. And okay, so yes, so here you will. So these are the challenges, right? Right. So Vivek's point is the space is not fully utilized. One drive may be overutilized, meaning uniform data distribution. Good, good, great. Great. So yes, these are the following challenges with the design which we just discussed. First, there was no failover or backup. In case one machine goes down, then the data is lost. Okay. Even if we set up something like a RAID system on such that for each hard disk we have a backup hard disk keeping the same data replicated. Still, failover will not be solved by RAID. Okay. Now, one disk might be very heavily utilized. As we said that let's say we put all the data starting with A into first one and then starting with B into second one. So uh, you will see that all the data that starts with Q, okay, that drive will be very empty. The drive that was supposed to store the data starting with Q will be fairly empty. So the data distribution is not uniform. So next is this best value for money? Are we utilizing the resources properly? We bought 100 new hard disks happily, okay, and we might be having some 200 GB hard disk, 100 GB hard disk, 80 GB hard disk, 40 GB hard disk. Are we utilizing that? Are we making the proper use of our resources? If we used 40 GB hard disk in this network would further become so big that it will become unmanageable. What about increasing accessibility? This is very important. Imagine that, imagine that there is this file. single file containing a particular movie which is recently released, and everybody wants to watch that particular movie. Okay, so that movie, or the machine containing that particular movie will be overloaded with the request, or the drive, the hard drive can only read one, can only do the single read at a time, right? It can only cater to one user at a time. Therefore, that particular hard disk will be heavily overloaded, that hard disk containing this particular movie. Okay, now scaling out means today you have 100 terabyte requirement, tomorrow you might have 120, next day you might be having 150 terabyte requirement, and so on. So can we scale out? Scale out means scaling. So so can we scale out? Okay. If we add more machines into this network, what would happen is it will, if you add more machine into the network, the data need to be rebalanced. Data need to be moved to this new machine. Okay. All right. So the solution is to go for a big data file system such as HDFS. Okay. Now Suresh's question is, what is the difference between Hadoop and big data? So big data is a problem and Hadoop is a solution. Okay. So that is probably my shortest answer, Suresh. All right. Now you can see that how does HDFS solve the problem? So let's get down into this. Okay. All right. So HDFS is made up of these two kind of nodes. What are these nodes? Each node is nothing but a computer. Okay. So HDFS contains two kinds of services. One service is admin node, other is called data node. These are services because these services are running as a network daemon on each machine, network service on each machine listening to a particular port. Okay, so there are two kinds of nodes. One is data node, other is admin node. The way the way somebody said that we will need to index something earlier when we were discussing file system, so that indexing is done in admin node. So admin node knows which file is where. Admin node has this information. So, admin node, which is a part of HDFS, knows where is the data, while data nodes contain the data. Okay, so it's like we distributed the data, but we kept an index of which file is where. All right. So in HDFS, you have two kinds of node: admin node and data nodes. Admin node knows which data is where, and data nodes contain the actual data. Admin node contains this information, and we call this metadata, meaning this is a data over data. This information, this index, is called metadata, and this information is kept in the disk as well as in the memory on admin node. In case admin node shuts down, there is a backup of admin node, okay, which will quickly overtake and will start acting like a name node. Okay, we'll talk about it again. Now, next thing to understand is next thing to understand is the files which we are going to store in data nodes. We split these files and then create the blocks, each of 128 MB. The last block will generally be smaller because not every file will be a multiple of 128 MB. So if you have 200 MB file, one block will be 128 MB and second block will be, anybody, 72 MB. So so basically each file is split into the blocks. Okay, each of 128 MB size, except for the last one, which will be smaller generally. And and these blocks are basically distributed across the data nodes. The objective of these blocks is they help fitting the big files into small disks. These leave less unused space on the disk and optimizes the data transfer. Okay, these optimize the data transfer. Also, it distributes the load to multiple machines. All right. Okay. So when you break a big file into 128 MB blocks, it becomes more mobile. You can redistribute the blocks very quickly. Similarly, copying one block to another is easier, and you can utilize this space far better way. If you are trying to say store uh, a full file, that means you need to have the space available for full file. But here, since the blocks are small, therefore, okay, makes sense to you? Now, Vivek's question is why not less than 128 megabytes? So you're talking, you say 120 bytes, right? I'm assuming that you're talking about 128 MB. Yeah. So if you create uh, smaller blocks, what will happen is there'll be too many blocks. If you create a bigger block, then most of the file will have a single block. There's no point of having the blocks, the splits then. Okay, so it's a very abstract and very arbitrary, but has been done keeping in mind various kinds of parameters. Okay, earlier it was 64 MB, now it's 128 MB. Now these each block, what we just talked about, has multiple copies. Okay, it's like backup. So each block is copied by default to two more nodes, meaning total number of three copies. In case one data node containing blocks fails, all the blocks will get copied again to another node. Okay. So because the moment one data node goes down, only one copy of the block has gone down. Still, there are two copies available. Using these two copies, a new copy is generated, which means again the total number of copies of a block will become 3. Okay, and that is how the replication happens. That is how the high availability is ensured, and that is how even a failure of data node does not impact a file. Okay. Now, Veena's question is, in the previous example, for accessing a particular movie, user will be connecting to different data nodes. Won't that be, won't that make it slower? No. Okay. So while accessing these multiple files, multiple blocks, it won't be that slower. Okay. And also, unlike the expectation that the user will come to name node will read the data from each data node, it doesn't happen that way. Otherwise, name node will become the bottleneck. The architecture is like this. You ask your command line, that is client driver, that get me the file. This client driver goes and asks name node, hey, can you tell me where are the blocks? And name node gives the list of blocks to the client. Now client goes directly to the data nodes and starts reading the data. Okay. Make sense to you? So this is how the, again, the same architecture. So basically the client is, if client is going to read the data, client goes to the name node, and name node gives the list of data such as which block is on which machine and which, how many copies are there, and so on. And this client, the client library will assemble the file for you and give you as a single file. So for as an end user, you do not have to deal with all of this. This client driver, this client library, the command line which will you will use for uploading, downloading data, will do all the assembling and breaking into blocks. Okay, this command will break the files into blocks and upload it onto the data nodes. Again, this client driver, whenever user wants to write the data, what does this client driver do? Client driver first goes to name node, that saying, hey, I want to create a particular file. Now this name node responds saying that, okay, go to data node 2 and 3. There you can store your file. And once you are done with storing that file, come back to me and confirm. Okay, that is how the HDFS works. Hi Suresh. So Suresh's question is why Hadoop and big data are essential for software industry. The reason is you can't handle the kind of big data are we talking about. You can't handle that kind of big data using usual tools, and therefore you require these new tools like Hadoop. Okay, go through this video recording, or you go through the recording which is available on our website. You will understand the first discussion we had in this session was about exactly these topics. Okay, so I'm hoping that you'll be able to go through that one. All right, so that was it. Now we, again, lots of people have questions regarding our cloud labs, so you can go through, so those who have signed up will get an access to cloud labs, and you can go through cloud labs where you can access the HDFS. So like for example, I'll just give you a quick preview. So this is how HDFS looks like. Okay, so you have this file system. These are the folders. These are the files under it. Okay, and so although these files, these files are existing on multiple machines, but to you it looked like a singular folder. Okay, so whenever we are asking for listing, this this application, this file browser is going to name node and collecting this metadata and displaying it to you. Okay, all right. So this is how it looks like, and we will have a more detailed exercise on how to access cloud labs and how to access Hadoop. Okay, so Cloud Lab we have installed Hadoop and all necessary tools so that our student don't have to install virtual machine, because when you install virtual machine you require bigger RAM and all that. But having said that, we always support students to install the virtual machine also. Okay, so it is up to you whether you want to go for virtual machine or both or cloud labs. All right. Now we have okay. So on our cluster we have Ambari and okay. All right. So you can connect to the cloud, finish the quiz if you have already enrolled. And those who have not enrolled, these are the courses available. And yeah, these are the courses available, the upcoming courses. Next one is starting on 11th of July, 8:30 p.m. And there is another course starting on 25th July, and that will be on 7 a.m. And every Saturday, Sunday for 3 hours. So minimum RAM, Revati's question is what is the minimum RAM for VM? Minimum RAM, it requires more than 4 GB. Okay. Otherwise it will be too slow. Alright, so yeah, these are the upcoming courses. You can enroll for our courses. 11th July one will be similar to this one. That's correct, Veena. And from 12th July, it will be second session, and then we'll continue with the rest of the course. Okay. 11th July and 25th July will be the same as today. Okay. So these are the courses that will start because this is a session one. Okay. And the session one is open for all. All right. So if you have any questions related to anything, you can just email to us at reachus@nobigdata, and we will be able to answer you. All right. So feel free to drop us an email. Okay. All right. Thank you. Thank you, everyone. Have a great day ahead. All right. Thank you, Ram. Thank you, Veena. Thank you, Madhi. Thank you, Joseph. Thank you, Gaurav. Thank you, Ravi. Thank you, Sefer. All right. Thank you, Madhi. Have a good day. And thank you, Vivek. Thank you, Suresh. Thank you, Pranay. Thank you, Venugopal. All right. I'm happy that it was very helpful to you. Thank you, Arun. Thank you, Shivam. Thank you, Kiran. Thank you, Krishna. Thank you, Arun Kumar. Thank you, Rajesh. Have a great day. Okay. Thank you, Harsha. I'm happy that you found it helpful. Thank you, Vidhi. Have a great day. Thank you, Garud. Thank you, Mayur. Have a great time ahead. Thank you, Anagi. All right. All right. So feel free to enroll for the course. You can go to the website. You can basically go to the website and enroll for the course. Okay. All right. All right. Then I will hang up now. Okay. Thank you, everyone. Have a great day.